Okay, today we are doing our last day of notes. This is graphing rational functions. So a helpful acronym when you are graphing rational functions is RATE. A helpful acronym when you are graphing rational functions is RATE, and it comes from not that. Roots, asymptotes, togetherness, and behavior, and y-intercept, RATE. Before you can get started, you have to make sure that you factor everything, the top and the bottom, everything needs to be factored. You have to make sure everything is factored. Once you are factored, sometimes things cancel out. Hello? When you factor everything, sometimes things cancel out or they simplify. So when a factor cancels or it gets simplified, that means there is a hole because you are removing that factor. So when you remove a factor, x cannot be equal to any factors that you remove. And when you have a hole, you're going to put a hole in your graph. For the roots are x equals, and we're going to mark them on our graph with a point. You can list your x-intercepts or your roots. You can list them as x equals. You could also list them as a point, and it will always be whatever the x value is, comma 0. I don't really care how you write them. Either one is fine. So that is the R part of RATE. A stands for asymptotes. You can have two different flavors of asymptotes. We learned this last time when you had horizontal and vertical. The A for this stands for the vertical asymptotes. So you see that V that was already there, you can turn it into a line. It goes like that. It is a vertical asymptote. Asymptotes are where your graph does not live. Your graph does not live there. Your graph cannot cross. And so if you want to say x is not equal to, that's fine because it also affects your domain. So your graph cannot cross. Asymptotes are going to be marked on your graph, and these are going to be marked with a vertical line. And you can mark it with a highlighter, like we did last class. For togetherness, we've talked about togetherness last class, and when we talked about togetherness, it was around an asymptote. And so if you are at an asymptote, your graph will go together, and it looks like that. And that's what we call togetherness around an asymptote. So around an asymptote, that's what it looks like if your graph has togetherness. At a root is a point. So at a root, if you have togetherness, your graph will go together. They will leave the root and go together. When you're looking at your equations, so roots always come from the top, and then asymptotes come from the bottom. So your factors from the top will give you the roots. And so that's also why it's in this order. So the things on top give you the roots, the bottom gives you the asymptotes. An information wave. An information wave is going to be like a number line. And you're going to have labels on it. And we will label you're going to label with the values from raw. So whatever you get for R and A, you will use these values, whatever you get, and you will put them in order and make it like a number line. Everything that we're graphing in here is going to be a positive graph. It doesn't mean that graphs can't be negative. It's just what I'm giving you. It's going to be positive graphs. Because they're positive, we will begin on the top because it's positive. And all you're going to do, and you always start on the right, all you're going to do is weave through those values. That's it. And the only time that that will ever change is if you have togetherness. When you have togetherness, we will bounce, but more often than not, there isn't. So you just weave through. And this is going to tell you how to graph. Okay, this is an information wave, and it tells you how to graph. Next, we have end behavior. And so end behavior, it makes a horizontal asymptote. And if you look at the letter H, it's going to be like that middle line straight across. So when we mark this one on our graph, it's going to be a line, but it will be horizontal. There are 3 situations that you could come across, and you're talking specifically about the degree of your function. We will not do anything with a bigger top. You have to divide. But we're not going to be doing any of those. If you go on to pre-cal, you will, but we're not doing them in here. What that means is that the degree on the top is bigger than the degree on the bottom. So you might have a situation like x to the 3rd over x squared. Something like that. Your degree is bigger on the top. When your degree is bigger on the bottom, so that's a situation like x squared over x cubed. If you've got two x's on top and 3 on the bottom, it will always be y equals 0. Every time. When it's the same degree on the top and the bottom, what you're looking for is the ratio of the coefficients or what is in the front. But for what we're doing, it's going to be a 1. So your equation becomes y is equal to 1. So the two that you use pretty much all the time are these two. When you're graphing, these are the things that are going to be marked with your with your highlighter. So you might connect those. Those are both going to be highlighter things. These are things that you will highlight. Your y-intercept, the y-intercept, you can list it as y equals, or you can list it as a point. If you list it as a point, your x value is 0, and then you figure out what your y value is. To figure out your y value, you will plug in 0 for x. Okay, to figure out your y-intercept, you will plug in 0 for x. And when we mark the y-intercept on your graph, it will also be with a point. All right, we are ready to figure some of this stuff out. So question number 1, are you factored completely? No, we still need to factor the denominator. So I'm going to factor, the top looks fine. To factor the denominator, I know I'm going to have 2 factors. I'm going to have an x and an x. And the only way I can multiply to get 2 is with 1 and 2. My middle term is negative, so my bigger number needs to be negative. If I have -2, I would have to add 1. If you still struggle with factoring, then you might want to watch a YouTube video. Bless you. Now, are we completely factored? Yes. So we can say, yep, we are factored. When we take a look at our factored function, are there any factors that can cancel out? We've got that factor that can cancel out. That means that we're removing that from our function, so there will be a hole. So if the factor is x minus 2, then where is the hole going to be at? It's always going to be opposite of what it is in the factor. So if the factor is x minus 2, then where is the whole going to be? It's going to be at plus 2. So x cannot be equal to 2. There's a hole. Okay, so for raw, remember that this is the top and then the bottom. It goes along with your, goes straight down. So we'll figure out from the top, you only have one factor left, x minus 4. So if the factor is x minus 4, then what does x equal? 4. There's no more factors on the top, so we are done. For the asymptotes, we look at the bottom. The factor is x plus 1. So what can x not equal? What? You want to remind yourself, our asymptotes are going to be highlighted when we go to graph. Togetherness, are any of those factors squared? No, so there's no togetherness. This is a positive graph. I'm not giving you any negative ones. So I'm going to draw an information wave. And I'm going to mark it with only values from raw. That's how I label it. And I have to put them in numerical order. So it would go -1 and then 4. Don't put a 0 because 0 is not one of the values. You only label it with the values you see. This is positive, so I will start on top. I'm always starting on top. And then I just weave through because there's no togetherness. It doesn't really make a whole lot of sense until we actually start graphing, but that's a very useful piece of information. Our end behavior, that depends on how many x's that there are. So what I'm going to look for is on the top. How many x's do you see? 2. And then that says there are 2. So what you end up with, that's the same. So what is the equation when they're, or sorry, what is it when they're the same? Look at the top. So this is also going to be an asymptote. So y is not going to be equal to 1. To figure out what y is, you're going to be plugging in 0 for x, and it's easiest to do it. You can do it once you've removed these factors, that's fine. So the simplest one that I have is one factor on top, one factor on bottom. So if I plug in 0 for x, what's 0 minus 4? And then what's 0 plus 1? Okay, so what's -4 divided by 1? When I go to graph this, the top and the bottom, those are going to be points. And those are going to be asymptotes. Let's do another one. So example 2, is it already factored? No, so we need to factor the top. When I look at the top, I think of two things that I can multiply to give me 30, that I could add to give me 13. Yep. 10 and 3. My middle term is positive, so the bigger number will be positive. Now I am factored. Now I look through, are there any factors that cancel? No, so there are no holes. You would say there are none. The roots are going to come from the top. So what does x equal from the top? -3 and -10. Very good. And those are going to be marked on my graph with a point. The asymptotes are going to come from the bottom. They're going to be highlighted just like the end behavior. They make vertical asymptotes. Looking at the bottom, I have two x's, so I will have two asymptotes. X cannot be what two values? 0 and -2. Very good. Togetherness, is anything squared? Nope, none of the factors are squared, so there is no togetherness. Using raw, I will make my information wave. I've got a lot more values, but I still have to put them in numerical order. So it looks like the smallest one is at -10. And I have -3, -2, and then 0. So I will mark my information wave with all the values from raw. This is a positive function, so I'm going to start at the top. There's no togetherness, so I will weave through at every tick mark. And that is it. Hello? I do. Sure, no problem. Josh, you have something in the front office that you go to the attendance person. The end behavior. How many X's are on the top? 2. How many are on the bottom? 2. So the situation we have is 2 on top and 2 on the bottom. They are the same. What happens when they are the same? Y is not going to be equal to 1. That's going to be your horizontal asymptote. For your y-intercept, you're going to plug in 0 for x. So when you plug in 0, you end up with 3 times 10 on the top, and then 0 times 2 on the bottom. Three times 10 is 30, and 0 times 2 is 0. What happens when you divide by 0? It's undefined. So if it's undefined, that means that there is no y-intercept. There isn't one. Example 3, is it factored? No. Looks like the top is factored, but I need to factor the bottom. Yep, 5 and 3 can multiply to give me 15. The middle number is positive, so the bigger number needs to be positive 5, and then you'd have to take away 3. So now I am factored. Are there any factors that can be removed? No. So there are no holes. Roots. Roots will come from the top. And so what are my x-intercepts or my roots from the top? -2. And we're going to mark them on our graph with a dot. My asymptotes, I'm going to mark with a highlighter. And looking at the bottom, what can x not be? Very good. X cannot be equal to -5 or +3. Are any of those factors squared? No. So there's no togetherness. I'm going to make an information wave using raw. That means that I'm going to mark it with the values from R and A in numerical order. The smallest one is -5. This is a positive graph, so I'm going to start at the top. And since there's no togetherness, I'm going to weave through. That is going to help us when we get to graph. For the end behavior, how many x's are on the top? For the end behavior, how many x's are on top? 1. How many x's are on the bottom? Okay, what happens when you're bigger on the bottom?
0.
Yep, y is not going to be equal to 0. That's going to be our horizontal asymptote. You are. And to figure out our y-intercept, which we will mark with a point, we're going to plug in 0 for x. So we end up with 2 over 5 times -3. That's 2 over -15. Does 2 over -15 reduce it all? No, it's ugly, but who cares? So your point would be 0 and then -2 over 15. It just is what it is. You're going to look on the very back of your final exam review and the last 3 questions. You are going to go do those now. So using using your notes so far, you are going to look on the very last page, the very last 3 questions, and you're going to answer these. So you guys should have finished the last three problems. Those of you that didn't, I don't know what to say. Wait, where? Of the last three problems on your final exam review. That's what it says on the board. Use your notes.
Condition numbers up there. Condition what do we do? Because we did it with one number. So
Then you just list two of them, but the vertical asymptote, that's A, so it's just two values there.
so you just multiply this here. Or the one.
Nope, it's this. The A, X cannot be equal to whatever the values are on the bottom. So we just did that because the last two had two values in the bottom. Agree? All right, before we move on to the back, we're gonna do round two. Oh, I meant thief. Good job.
Detective. Magician. Politician.
Very good. Oh, that would be a good one. Okie dokie, we are gonna flip over the paper. And now we're actually going to start graphing. So before we can graph, we need all of the information for 4. So is it factored? Is number 4 factored? Yes. Are there any factors that can be removed? All right, our roots are gonna come from the top and we're gonna mark them with a point. So what does x equal? Spit it out. 0. Very good. For the asymptotes, thank you. For the asymptotes, and they're going to be vertical asymptotes, what can x not equal? Is there any kind of togetherness? Are any of those factors squared? We're going to make an information wave and we're going to use raw. I'm going to mark it with only the values from R and A. This is a positive graph, a positive function. So I'm going to start on the top and I'm just going to weave through because there is no togetherness. Both of my asymptotes are going to be marked with a highlighter. E is going to make a horizontal. And I figure that out by looking at how many X's are on top and how many are on bottom. So how many X's are on the top? 1. How many are on the bottom? Okay, when it's the same. Not 0. 1. That's when you're bigger on the bottom. For my y-intercept, I'm going to plug in 0 anywhere that I see X. So I end up with 0 on the top and then 5 on the bottom. What is 0 divided by 5? So my point would be 0, 0. So we are ready to get our graph prepared. To get your graph prepared, you are going to start with these things, the things right here. That's where you start. Okay, that's where you start. I always have students that say, I don't even know where to start. You have to start with those things. You have 2 points and you have some asymptotes. So I'm going to go mark them. My y-intercept is at 0. So is my x-intercept. They're the same. For my asymptotes, I'm going to have one at -5. And it goes that way. And then I'm going to have one at 1 and it's going to go that way. So I can go mark them. So I have marked my graph with all the things that it says. So we need to remember something. We need to remember that your graph really likes asymptotes. It wants to snuggle up next to an asymptote, but you can't cross them. So we're going to use the information wave to help us sketch this graph. To sketch this graph, we're going to graph it in as many pieces as we see on our information wave. What I mean by that is here is a piece, here is a piece, here is a piece. So you're going to have 3 different pieces to your graph. The information wave tells you when you are going to be above or below the x-axis. The information wave tells you when you're going to be above or below the x-axis. So the way we use this information wave, it says that from 0 to forever, your graph is going to be above the x-axis. So here's 0. It says from 0 to forever, you're going to be above the x-axis. Well, we're going to graph above the x-axis, but I have to follow the path of the asymptote. So my graph will look like that. That's my first piece. For my second piece, it says that my graph is below the x-axis. So that means from -5 to 0. So here's -5 and here is 0. My graph's going to be below the x-axis. That kind of makes sense because we know that these graphs kind of make little curves. So it's going to curve down. And you're going to kind of go over close to the asymptote. For the third part of my graph, it says that it's going to be above the x-axis. Are there any intercepts over here? Do I have any dots over here? No, there is only one, and we've already marked it. So that means you cannot touch again. So you have to use the path of the asymptotes, and it will make the second branch over here. Okay, before we move on, we're going to do the next round. I know, I'm kind of disappointed. Let's see if we can redeem ourselves. Oh my goodness. Okay, we did much better. We did much better. Okay, for question number 5, is it factored? No. Looking at the numerator, that is a special kind of factoring. What does it become? Yes. X plus 5, X minus 5. Are there any factors that can be removed? So there's going to be a whole, and X cannot equal what? Good job. My roots are going to come from the top. So what does X equal? Very good. My asymptotes, I know that they're going to look like that. And I'm going to highlight them. What can X not be equal to? 0. Is there any togetherness? Where? We have an X squared. That means that the togetherness is going to be at 0. I'm going to make my information wave, and I'm going to do it with the values from raw. I only have 2. I have -5, and I have 0. But at 0, I have togetherness. So I'm marking it at 0. There is togetherness. I'm putting a little dot there because there is togetherness. Normally, we weave through. When there is togetherness, we do not. We bounce. When there is togetherness, we do not weave through. We bounce. And then you continue on. Normally, you just weave through. But when there is togetherness, you bounce. The end behavior, looking at the function, how many X's are on top? Okay, fine, we can do that. You can do the simplified one. And how many are on the bottom? Okay, so you're bigger on the bottom. So what can, y is not going to be equal to 0. For my y-intercept, I would mark it with a dot. And I'm going to plug in 0. So I would get 5 over 0. What is anything divided by 0? Undefined. When it's undefined, there is no y-intercept. Very nice. Before we move on, we will try and redeem ourselves with the money round.
Name something you have to put with if you live, you know, something. If you don't-
Nothing.
Up, put up. Name something that gets slammed.
Doors.
Something like that, job I mean. Name something that might touch short hair. Name something that long more might accidentally go over.
Rock.
Okay, y'all didn't do as bad as you have on the board, but yeah, I think that your high score is 1600. Okay. For 6. Is it factored? No, so we need to factor it. So if I need to multiply to make 12, add to make 4. I could do 2 and 6. Now that I am factored, are there any holes? Any factors that I'm removing? Very good. So there is a hole, and x cannot be equal to what? -2. There's a hole at -2. So one thing I can do is go over to my graph, and I can jot that down that I have a hole at -2. I forgot part of this question. It says, what are the solutions? The solutions for anything are what? X-intercept. So do we have one? Where? That's your solution. All right, when I go to make my roots, I'm going to put them as points. They come from the top. So what is x going to equal? Very good. My asymptotes are going to be marked with a highlighter. X cannot equal what? -4, very good. Is there any togetherness? For my information wave, I'm going to mark it and I'm going to use raw. I will label it with only things from R and A. So I have -4 and +6. My function is positive. Since there's no togetherness, I'm going to weave through like normal. For the end behavior, how many X's are on top? How many are on bottom? So what is your end behavior? We're going to graph it, and y cannot be equal to 1. When we put our y-intercept, we can plug in 0 for x. So we get -6 over 4. Does that reduce? So we're going to put a point at 0 and then -3 over 2. That's also 0 and then -1.5. That'll be a point. When you're doing your homework and you don't know where to start, you will start with these things. We're going to start marking our graph with those things. So we have x is equal to 6. Y is equal to negative 1.5. We're gonna have asymptotes. We're gonna have our vertical one at -4 and the horizontal one at 1. And so that will be where I'll put my highlighter. Now we will use our information wave to help us make our graph. There's 3 pieces to my information wave. I've got 1, 2, and 3 pieces. For my first piece, at 6, from 6 to positive infinity, is my graph going to be above or below the x-axis? Above. And there's an asymptote, so I can't just go straight up. The next little window or interval is from -4 to 6. So it's from this asymptote all the way to this point. So it says all of this right here, am I going to be above or below? Below. And we have a y-intercept. So when we go below, we're going to go through the y-intercept and then continue on down. And then our pole is at -2. So wherever your graph is, you can erase it and you can put a hole there. My last little part, is it going to be above or below the x-axis? Above. And so it's going to use the asymptotes like we did last class.